In 1a, we need to simplify m squared raised to the power of 3, and we know that when we've got a power raised to a power, we multiply the indices together, so we're looking at m raised to the power of 6. In b, we need to simplify x to the 5 times x to the 8, and when we multiply with a common base, we add the indices, so 5 plus 8 is 13, leading to x raised to the power of 13. In part C, we need to expand 4p times p squared plus 3p. So 4p times p squared will give me 4p to the power of 3, and 4p times 3p will give me 12p squared, so plus 12p squared. In question 2, Johnny wants to know how much coffee he will need for 800 people at a meeting. Well, each person that drinks coffee will drink 2 cups, and we need 10.6 grams of coffee for each cup. We are assuming that 68% of the people will drink coffee, and under this assumption, we need to work out the total amount of coffee Johnny needs, giving our answer correct to the nearest gram. Well, I will start by calculating 68% of 800. This will give me the number of people that we expect to drink coffee. It gives an answer of 544, and now each one of these 544 people will have 2 cups, and each cup will need 10.6 grams. So if I do 544 times 2 times 10.6, I get an answer of 11,532.8, which means that to the nearest gram, we're looking at 11,533 grams of coffee. Now, Johnny's assumption is wrong, and actually 72% of the people will drink coffee. How does this affect our answer to part A? Well, 72% is more than the 68%. Therefore, we've got more people asking for coffee, and therefore this means that more coffee will be needed. In question 3, we are told that ACF and ADG are straight lines, then BCD and EFG are parallel lines, and we need to show that triangle ACD here is isosceles, giving a reason for each stage of our working. Well, actually, we need to construct the proof here. That's why we need the reasons. Now, before going into the reasons, let me look at the triangle here. We are told to prove that this is isosceles, so one option is proving that 2 sides have the same length, or alternatively, 2 angles are of the same size. Well, there are no lengths involved here, so it has to be based on the angles. I start by noticing that the angle ADC here must be 180 minus 110, which gives me an answer of 70. So the plan is to go through the angles, first of all, to establish that I've got 2 angles that are of the same size, and then I'm going to go back and add the reasons. Now, from the 125 here, I can see that the angle CFG is going to be 180 minus 125, which gives an answer of 55 degrees. And using the fact that the line EFG is parallel to BCD, we can conclude that the angle ACD here is also 55 degrees because these 2 are corresponding, and therefore I can go to the final angle A here and use the angle sum being 180 within a triangle. So this is 180 minus the 70 and the 55, which gives an answer of 55 degrees. So there it is. I've got 2 angles of the same size, so I need to go back and add the reasons. So let's see, the first thing we say is that ADC, the angle here is 70 degrees, angles on a line add up to 180 degrees. I will then proceed stating that CFG, the angle here is 55 degrees because angles on a line add up to 180 degrees. I will proceed with the angle ACD. Corresponding angles are equal, so ACD is 55 degrees. And finally, the angle A, so the angle CAD is 55 degrees. Angles in a triangle add up to 180 degrees. So the only thing missing here is an overall conclusion because we are constructing a proof. So since CAD is equal to angle ACD, the triangle ACD is isosceles. In question 4, we are told that it takes 14 hours for 5 identical pumps to fill a water tank. Now the question is, how many hours would it take 4 of these pumps to fill another water tank of the same size? So the first thing to do is to observe that the greater the number of pumps, the less the time needed. So these two quantities are inversely related, and when two quantities are in inverse proportion, then their product is always the same constant value. So in this case, time times the number of pumps will be constant. So we've got 14 times 5 to be equal to x, which is the hours we're trying to find, times 4, which is the number of pumps we have. So 70 is equal to 4x, which leads to x being 17.5, and therefore we will need 17.5 hours. In question 5, we're given a and b here, two numbers decomposed into powers of prime factors, and I need to find the highest common factor of a and b. Well, we know that for the highest common factor, I will choose the common factors to their lowest power. So I'm going to choose 3 to the 2 and 7. So 3 squared times 7 is the highest common factor, which evaluates to 63. Now for the lowest common multiple of a and b, I will be considering all prime factors raised to their highest power. So I'll be choosing 2 squared, 3 to the power of 4, and 7 squared. So we're looking for the LCM, which is 2 squared times 3 to the power of 4 times 7 squared, which when plugged on the calculator gives me 15,876. In question 6, we've got lava flowing from a volcano at a constant rate of 11.9 cubic meters per second. The question is, how many days will it take for this amount of lava to flow from the volcano? Give our answer correct to the nearest day. So we know that in 1 second we've got lava equivalent to 11.9 cubic meters flowing out. So x seconds to get the 67,205,600 cubic meters. This means that x is 1 times the 67,205,600 divided by the 11.9, which gives an answer of 5647529.412 and this is seconds. Now be careful here, we need to give our answer in terms of days to the nearest day. So to go from seconds to hours, I will divide by 3,600, which is the number of seconds within an hour. If I divide by 3,600, I get 1568.758 hours. And then to go from hours into days, I'll divide by 24 since we've got 24 hours in a day. This gives an answer of 65.3649 days, and therefore to the nearest day we're looking at 65 days. In question 7, we're given the graph of y is x squared minus 2x minus 2, and we need to write down the coordinates of the turning point on the graph of this curve. Well, the turning point is the minimum here, and I can read off the coordinates. X is 1, y is negative 3, so the coordinates are 1, negative 3. For part B, we need to write down an estimate for one of the roots of the equation x squared minus 2x minus 2 is 0, which is exactly what we have plotted here. So the roots of this equation are simply the cuts on the x-axis. So we can give either the positive root or the negative root. Well, for the positive root, I can see that it is 2.7. So I could say x is 2.7. Or for the negative root, I can see it's negative 0.7 or x is negative 0.7. Notice that you don't have to give both of these. The question is only asking for one of these roots. So either of these two should give you the mark. Question 8, we've got a solid cuboid made of metal. We've got the density of the metal being 9 grams per cubic centimeter and the volume of the cuboid being 72 cubic centimeters. and we need to work out the mass of the cuboid in grams. Well, we know that density is mass over volume. We've got the density, it's 9. The mass, I'm going to call it M. It's what we're trying to find here. And the volume is 72. So let's cross multiply. 9 times 72 is the mass, which gives an answer of 648. And therefore, we conclude that we're looking at 648 grams. In question 9, we had some people asked if they wanted a new television. Now, 70% of the people said yes, and 80% of the people who said yes wanted a television with a large screen. The question is, what percentage of the people asked said they wanted a television with a large screen? So we know that the 80% of the 70% is what we're trying to find. Now the word of means multiplication. 80% is the fraction 80 over 100 times 70 over 100. This gives an answer of 56 over 100, and therefore we conclude that 56% of the people asked were asking for a television with a large screen. In question 10, we've got A, B, D, a triangle, and C is a point on BD. Now we need to work out the length of DC, and we notice that both triangle ACD and triangle ACB are right angled, so I'm using SOHCAHTOA here. I will start by looking at triangle ACB, which I'm highlighting here in blue because I've got an angle and a side. So we notice that AC is a common side between the two triangles. We can see that the 6.8 is the hypotenuse and the AC is the opposite. So if I find the opposite here, the side AC, I can move on to triangle ACD, which I'm highlighting in red, for which we know that AC is the opposite and DC is the adjacent. So let's start with the triangle ACB. We have that sine of 41 is equal to AC over 6.8. I will cross multiply to get that 6.8 sine of 41 is equal to AC. I'm not rushing to the calculator. I will keep the AC as it is and I proceed. We've got tan of 55. Tan is opposite over adjacent, which is the AC over the DC that we are trying to find. I will cross multiply again. We've got DC tan of 55 being equal to AC, which we know is 6.8 sine of 41, and therefore we have that DC is 6.8 sine of 41 over the tangent of 55. Now it's the time to put this on the calculator. Get that DC is 3.12376 ... Well, we've been asked to give our answer correct to one decimal place, and therefore we conclude that DC is 3.1 centimeters. In question 11, we've got the table showing information about the heights of a group of adults. So we've got the least and the greatest height, the median, the lower and the upper quartile, and we need to draw on the grid provided a box plot for the information in the table. So we start by plotting the box, which goes from the lower quartile to the upper quartile, and the median is at 177, and then it spans from the least height of 169 up to the greatest height of 186 centimeters. In part B, we're given the box plot showing the distribution of the heights of a group of teenagers, and we need to compare the distributions of the heights of adults to the distribution of the heights of teenagers. So essentially we need to look at these two box plots and compare them. Now part B is worth 2 marks, so there are 2 comments we need to make. I will start by comparing location. We can see that the median height for adults is greater than the median height for teenagers, and therefore we can say that adults are generally taller than teenagers, and I need to refer to the median height being greater for adults. And then if we look at the interquartile range, we can see that the interquartile range for adults and teenagers is the same. This refers to the spread of heights, and therefore we conclude that we've got a similar spread of heights as the interquartile range is the same. In 12, we need to show that x minus 1 times x plus 3 times x minus 5 can be written in the expanded form shown here, with a, b, c, and d being integers. So I need to expand these triple brackets. I will start with the last two brackets here. So I'm going to keep the x minus 1. Now, x plus 3 times x minus 5. X times x will give me x squared. X times negative 5 is negative 5x. 3 times x is 3x. And then we've got the 3 times the negative 5, which gives me negative 15. I will collect like terms within this second bracket, taking me to x squared minus 2x minus 15. And I will proceed by expanding this bracket with the second bracket. So x times x squared is x cubed minus 2x squared minus 15x minus x squared plus 2x plus 15. I will collect like terms once more. So we're looking at x cubed minus 3x squared minus 13x plus 15. In question 13, we are told that an expression for the nth term of the sequence of triangular numbers is given by n times n plus 1 over 2. And we need to prove that the sum of any two consecutive triangular numbers is a square number. So I will start by considering the sum of two consecutive triangular numbers. So consider the nth and the n plus 1th term. So we're looking at n times n plus 1 over 2. This is the nth triangular number. And for the next triangular number, I will be replacing n with n plus 1. So we're looking at n plus 1 times n plus 1 plus 1 over 2. The objective is to arrive at an expression that corresponds to a square number. So we're looking at n times n plus 1 over 2 plus n plus 1 times n plus 2 over 2. Well, we notice that n plus 1 over 2 is a common factor, so I'll take that out, n plus 1 over 2, and within the bracket I've got n plus 2, which takes me to n plus 1 times 2n plus 2, and all of it divided by 2. Now I can further see a common factor of 2 within the second bracket, which takes me to n plus 1 times 2 times n plus 1 over 2. Obviously the 2 with the 2 will cancel out, and we arrive at n plus 1 squared. We should be able to recognize this as a square number, so all we are missing is a conclusion, and therefore we conclude that the sum of any two consecutive triangular numbers is indeed a square number. In question 14, we're told that OAB here is a triangle and OBC is a sector of a circle centered at O. We need to calculate the area of the sector OBC, giving our answer correct to three significant figures. So if I highlight the sector, we know that the area of the sector is given by theta over 360 times pi r squared. Well, we've got the angle theta is 80 degrees, so we need to find the OB, the radius of this sector. So looking at the triangle OAB, I'll be using the cosine rule here to find the missing side OB, and therefore proceed in finding the area of the sector. So I will start with the cosine rule. We've got that OB squared is equal to 9 squared plus 6 squared minus 2 times 9 times 6 cos of 35. This leads to OB squared being equal to 28.53157 ... I will take the square root, and therefore we arrive at OB being 5.34149 ... So this here in the OB is the 5.34 ... which is the radius of the sector, and therefore I can proceed for the area of the sector OBC, which is going to be 80 over 360 times pi times the radius of 5.34 ... squared, which gives an answer of 19.918799 ... we were asked to give our answer correct to 3 significant figures, and therefore we conclude that the answer is 19.9 square centimeters. In 15a, we're asked to factorize a squared minus b squared, and we should be able to spot immediately that we're looking at the difference of two squares. So we've got a minus b times a plus b. Moving on to part b, we need to show that 2 to the power of 40 minus 1 is the product of two consecutive odd numbers. So this is part b of the question, so there must be a connection with part a. So I'm thinking that this is also the difference of two squares. So I'm considering a squared to be 2 to the power of 40 and b squared to be 1, which means that a is the square root of 2 to the power of 40, which is 2 to the power of 40 raised to the power of a half, and therefore we've got that a is 2 to the 20 and b is equal to 1. So if I just apply a being 2 to the 20 and b being 1 into the factorized form we obtained in part a, we can see that 2 to the power of 40 minus 1 can be factorized into 2 to the power of 20 minus 1 times 2 to the power of 20 plus 1. Now it's easy to spot that 2 to the power of 20 is even, and therefore 2 to the power of 20 minus 1 and 2 to the power of 20 plus 1 are both odd, and therefore we conclude that 2 to the power of 40 minus 1 is the product of two consecutive odd numbers. In question 16, we're given the grid here. We are told to enlarge triangle T by a scale factor of -2 with center of enlargement the point -2, -2. So the first thing to do is mark the center of the enlargement. So starting from any vertex, I will cover the distance to go to the center of the enlargement and multiply that by 2 and move on to the other side to find the image of each vertex of the original triangle. So if I do this for the first vertex here, it takes me to the point 6, -2. I'll do this for the vertex over here, taking me to 4, 4. And then for the -7, -5, we can see that we go over here to 8, 4. And therefore the image of triangle T is the one shown shaded here. In question 17, we're given a distance time graph, and we are asked in part A to find an estimate of the gradient of the graph at time 2.5 seconds, showing how we got our answer. So in this case, this is the point here, the 2.5, T is 2.5 here. I'm going to take my ruler and I will try and draw a line that just touches upon this point here. So I'm going to play around a bit with my ruler, maybe something like this. I'm trying to get the two distances to the left and the right to be similar. So this looks something like this, and then I'm going to draw a straight line corresponding to exactly the tangent, which is the line that just touches upon the point at which T is 2.5. So this is the line here. I will then identify 2 points lying on the line so that I can proceed with calculating the gradient. So I'm going to take the endpoints on the right hand side. We can see that we are at the point 4.5, 56, and on the left hand side we are at 1.3, Well, we know that the gradient is rise over run. It's given by y2 minus y1 over x2 minus x1, which means we're looking at 56 minus 0 over 4.5 minus 1.3. This gives an answer of 17.5, which is my estimate for the gradient. Now, obviously, your answer depends on the straight line that you have drawn. We have all drawn something similar, but not necessarily identical, and this is why the mark scheme is accepting anything between 6.5 and 19.5. In part B, we are asked to explain what the gradient of the graph represents. Well, recall that this is a distance time graph, so the gradient is the rate of change of distance with respect to time. So we can see that for every extra second, the distance increased by 17.5, which simply means that the speed is 17.5 meters per second. In question 18, we've got a solid frustum made by removing a small cone from a large cone as shown in the diagram. Now the slant height of the small cone is 6 centimeters the slant height of the large cone is 10 centimeters, and the radius of the base of the large cone is 3 centimeters, and we need to calculate the total surface area of the frustum, giving our answer correct to 3 significant figures. Well, first of all, let's agree that we're looking at the sum of the area of the base, the area of the top, so both of these are circles, plus the curved surface area of the frustum, and we're given the formula for the curved surface area of a cone. So I've got pretty much most of the measurements. What I'm missing is the radius of the small cone, and I'll be using similar triangles to find this. So I will start by shading the section here. So this triangle here and the big triangle are similar. Let me extract this situation to see exactly how to calculate the radius of the small cone. So we've got that the radius of the large cone is 3 centimeters, the slant height of the big cone is 10 centimeters, and the slant height of the small cone is 6 centimeters. I'll be calling the radius of the small cone x centimeters, and therefore we can see that if 6 becomes 10, then x becomes 3, which means that 6 over 10 is equal to x over 3. I will cross multiply to get 18 is equal to 10x, and therefore x is 1.8, and therefore I can proceed with the curved surface area of the frustum, which is given by the curved surface area of the big cone minus the curved surface area of the small cone. So we are looking at pi times 3 times 10 minus pi times 1.8 times 6, which gives an answer of 96 pi over 5. And we can therefore proceed with the total surface area of the frustum, which is given by the curved surface area we just found, plus the area of the base, which is pi r squared, so pi times 3 squared, plus pi times 1.8 squared. This is the top circle. This gives an answer of 786 over 25 pi, which when evaluated numerically is 98.771 ... which correct to 3 significant figures is 98.8 square centimeters. In question 19, Sana needs to draw the graph of y is 3 to the x for x between 0 and 4, and this is the graph that she drew on the grid here. Now we need to write down one thing that she did wrong. So we can see that this is passing through 0, 0. However, when x is 0, y should be 3 to the 0, which is 1, and therefore we are expecting the curve to pass through the point 0, 1. In question 20, we need to prove algebraically that 0.123 recurring can be written as 61 over 495. So first of all, the 2 dots indicate the repetition. So the first dot is the start of the pattern, and the second dot is the end of the pattern. So essentially, if I was to let x be 0.123 recurring, what we are looking at is the number 0.1232323 going on forever, and I need to show algebraically that this is the fraction 61 over 495. So the first thing to do, I will multiply by 10. So 10x is 1.232323 ... so that the number 1, which was not part of the pattern, does not appear in the decimal part. Now the decimal part is just the pattern of 23 repeating itself, and I want to get a full pattern over the left hand side of the decimal point. So I will multiply by 100. So 10 times 100 is 1000x, which is 123.232323 ... and what we have achieved here is that we've got the same decimal part, and therefore I can deduct one from the other. So 1000x minus 10x is 990x, being equal to 122, because simply the 2323 will cancel out, and therefore we've got that x is 122 over 990, which simplifies to 61 over 495, and therefore we conclude that 0.123 recurring is equivalent to 61 over 495. In question 21, we need to solve the equation 1 over x plus 4 plus 3 over 2 minus 2x is 1. So this is an algebraic equation involving fractions. The first thing to do is realize that the LCM here is x plus 4 times 2 minus 2x. I can consider the 1 here on the right hand side as being 1 over 1. So the first fraction, the 1 over x plus 4, needs to be multiplied with the 2 minus 2x. Then the 3 over 2 minus 2x needs to be multiplied with x plus 4. And finally, the 1 needs to be multiplied with x plus 4 times 2 minus 2x. The objective is to get rid of the denominator and therefore remove the complexity of dealing with a fractional equation. So we are looking at 2 minus 2x plus 3 times x plus 4 is equal to x plus 4 times 2 minus 2x. I will proceed by expanding the brackets to get 2 minus 2x plus 3x plus 12 is equal to 2x minus 2x squared plus 8 minus 8x, and therefore we've got x plus 14 is negative 2x squared minus 6x plus 8. I will be collecting everything on the left hand side, which takes me to 2x squared plus 7x plus 6, which factorizes into 2x plus 3 times x plus 2. So we have 2x plus 3 being equal to 0, or x plus 2 being equal to 0, which means that 2x is negative 3 or x is negative 2, and therefore we conclude that x is minus 3 over 2 or x is negative 2, a total of 2 solutions. Question 22 is on vectors. We've got the vector a times 2, 6 plus b times 8, 2 being parallel to the vector 13, 6, and we need to determine an expression for b in terms of a. So let's start by writing the vector we've got. It's a times 2, 6 plus b times 8, 2, which is of course 2a plus 8b and then 6a plus 2b. Now we are told that this is parallel to 13, 6, which means that the ratio of the I component to the j component of this vector is exactly the same as the ratio of 13 to 6. So in other words, I can say that 2a plus 8b over 6a plus 2b is equal to 13 over 6. I will cross multiply, taking me to 6 times 2a plus 8b being equal to 13 times 6a plus 2b. I will now expand to get 12a plus 48b being equal to 78a plus 26b, which leads to 22b being equal to 66a, and therefore b is equal to 3a, which is the final answer for question 22. In question 23, we've got a circle with the equation x squared plus y squared is 25. Now the point P with coordinates negative 3, 4 lies on the circle, and Alex claims that the tangent to the circle at P is crossing the x-axis at the point negative 8, 0, and we need to assess whether Alex is correct, showing clearly how we got our answer. Well, it certainly makes sense to start by drawing a diagram. So this is the circle here. It's centered at the origin. Now somewhere we've got the point negative 3, 4, and we're drawing the tangent, and we need to check, we need to investigate whether it is indeed the case that we cut the x-axis, so over here at the point negative 8, 0. Now we'll join the point negative 3, 4 with the center of the circle, the origin. So this is a radius, so the angle here must be 90 degrees. And therefore I will proceed by finding the gradient of the radius, because I've got 2 points lying on this line. So I'll be using y2 minus y1 over x2 minus x1. So in this case we're looking at 4 minus 0 over negative 3 minus 0, which gives an answer of negative 4 over 3. Well, we know that since this is a right angle, then the tangent here is perpendicular, and I will flip and change the sign to get the gradient of the tangent. So if the gradient of the radius was minus 4 over 3, then the gradient of the tangent is 3 over 4, and we know that we pass through the point -3, 4, so I will proceed in finding the full equation of the straight line corresponding to the tangent. So starting with y is mx plus c, we've got the gradient is 3 over 4, so y is 3 over 4x plus c, and we know that when x is -3, then we've got that y is equal to 4, and this means we've got 4 is 3 over 4 times the -3 plus c, which means 4 is -9 over 4 plus c, and therefore c turns out to be 25 over 4. So the equation of the tangent is y is 3 over 4x plus 25 over 4. Now Alex is claiming that when x is -8, y is 0. So let's check this. When x is -8, we've got that y is 3 over 4 times the -8 plus 25 over 4. This gives an answer for y which is equal to a quarter, which is of course not equal to 0 as Alex claims, and therefore we conclude that Alex is wrong. In 24, we've got a total of y counters in a box. Now we've got x pink counters, 5 blue counters, and the rest of them are green. Additionally, we are told that the ratio of x to y is 1 to 3, and Freda takes at random 2 counters from the box, and we need to find in terms of x an expression for the probability that she will be taking 2 counters of the same color, giving our answer as a fraction in this form. So let's draw up a table to see exactly what's happening here. We've got pink, blue, green, and the total. Well, we have been told that the number of pink counters is x. We've got 5 blue counters and a total of y counters. So the number of green counters should be y minus x minus 5. In addition, x over y is 1 over 3, and therefore this leads to 3x being equal to y, which means I can go back to my table here and update everything so that it is in terms of x. So in the place of y, I'm putting 3x, and in the place of y minus x minus 5, I'm putting 3x minus x minus 5, which simplifies to 2x minus 5, and therefore we can proceed with the probability we are asked to find. Well, we're trying to find the probability of 2 counters being of the same color, so essentially we're looking at the probability of getting 2 pinks, or the probability of getting 2 blue, or the probability of getting 2 green counters. So the probability of pink and then pink again, it's gonna be x over 3x times x minus 1 over 3x minus 1. Notice that each time I remove a counter, the total decreases by 1, and the number of counters of that color also decreases by 1. Then going to the blue scenario, it's gonna be 5 over 3x times 4 over 3x minus 1. And finally, for the green scenario, we've got 2x minus 5 green counters originally, and then if we remove 1, we are down to 2x minus 6 green counters out of a total of 3x minus 1 counters. Now I'll be expressing everything over the denominator of 3x times 3x minus 1, and looking at the numerators, we've got x times x minus 1 plus 20 plus 2x minus 5 times 2x minus 6. The objective is to simplify this algebraic fraction, so we're looking at x squared minus x plus 20 plus 4x squared minus 12x minus 10x plus 30, and all of it divided by 9x squared minus 3x. Now we'll collect the like terms together, and this takes me to 5x squared minus 23x plus 50, and all of it divided by 9x squared minus 3x.